So guys, okay guys, just before starting the session guys, can let me know guys, anybody has been joined for the today's class, if today is your first class? Anyone is there guys? You can there are multiple options are there. You can raise your hand, I think. Or you can just use a chat panel. Anyone is there guys who has been joined for the today's class? Everyone has joined yesterday's class. I think one or two guys are there. Okay, Manish. Okay, you are the first class. Anyone is there guys? Nothing is there guys. Just two classes has been happened. I just want to tell you like what has been happened in the two classes. That's it. Okay guys, I think one or two guys I can see guys who has been joined for the today's class. So guys, who has been, don't worry guys, because we are currently in the demo sessions only. We are currently happening the introduction part actually. Yes. Better to say that it's not like a demo, it's going to be some kind of an introductory part we are having it actually guys. Like two sessions has been happened, hardly it is going to be 45 minutes, 50 minutes class guys, because the class is going to be up to, we have taken only up to 10:30, hardly 10 minutes. If I started a little bit late, today I started at 9:45. So two sessions has been happened actually, guys. So just nothing is there. In the first session, I have just given some introduction, like how the data science, that means in data science, what we are going to learn. What are the different concepts which we are going to learn, like machine learning, deep learning. Just I given some idea about the what concepts we are going to learn it actually. So just the introduction, like how the machine learning, it has been introduced, how it is different from a programming language, just a small introduction class. And in yesterday's class, I have just told you, like in a machine learning project life cycle, what exactly we are going to do that. So what techniques we are going to learn. Just once again, quickly, I'll make you understand guys. Just a 5 minutes, I just review the class. So we have been started with some introduction part of machine learning, which is going to be a part of our data science actually, guys. So machine learning is a part of a data science and all these are part of your AI. So we can call this class as an AI class, but in the AI, we are going to be having deep machine learning first, then it is going to be deep learning, and then we have to go for the AI actually. I'll give an idea about that actually. Yes. So in machine learning, as what we discussed here is, machines are going to learn from the data. So once the machines are capable to learn actually, guys. So just if you give some a few instructions, automatically the machines can start learning from that particular data actually, guys. So data was given to the machine. Data was given to the machine, and machine is going to learn that particular data, understands the data, and it is going to give you some kind of an insights. Based on the insights, we are going to be doing some kind of a prediction actually. It's all about, machine learning is all about something like a prediction. So what could happen in the future? So what could happen in the future means to predict whether this customer who is applying a loan will pay the EMS promptly or not. Or whenever this person is getting these particular symptoms, in future he is going to be gets diagnosed with some an heart attack, or it may be some other the health related issues actually, or some kind of a medical diagnosis, whether he will be affected with the cancer or not. So in future, what could happen is we can predict something actually. So we are giving some data to the machine actually, guys. Whatever the past data was there, what has been happened in the past, that is what we call it as an experience. What is your experience? Based on that, the machine will understand from that particular experience, and what they are going to do is it will tell you this is what has been happened. Based on that, we are going to do some kind of a prediction what we can do it in the future. That is what about all about this particular machine learning actually, guys. Yes. Yes, absolutely. How it will impact the business if the prediction model goes wrong? Absolutely. So like, for example, there is going to be like a best example, we can say that. Let us say that we are predicting, we are developing a model which is going to be trying to predict a defaulter. For example, my model predicted as defaulter is not, he is not a defaulter. So the model has been predicted that the model has been predicted like defaulter is going to be is not a defaulter. It predicted actually. So what the bank has been done is, being it predicted that he is not a defaulter, the loan was approved. The loan is going to be gets approved actually, guys. But after 1 year paying of EMI, he has been stopped paying the EMIs. But what has been happened? It has been predicted as an S actual. So it actual happened is S, but predicted as a no. So this is going to be some kind of it's a wrong prediction has been got done. So what happens, you know, that the bank is going to be goes into some losses, isn't it? So because we have been predicting that it is going to be, so obviously that is going to be do some kind of a cost to the company. So our main target is to minimize this particular losses actually. We cannot say that in a banking application, I want to predict 100% accurately. So let us say that today, as of now, 30% of defaulters are there. At least we can bring them to, for example, a 15%, a 50% if you are able to decrease, automatically our losses are going to be gets decreases. Without a defaulters, the banks does not exist. But we are trying to minimize them actually. So how much it is going to be costing, that depends on that actually. It depends on the domain. For example, let us talk about a medical diagnosis actually. Yes, like it is going to be some kind of an cancer detections actually. So it is going to be nothing but a kind of a cancer diagnosis actually. Yes. So in a cancer detection, generally the cancerous cells is what we are going to use a term called as a malignant. And the non-cancerous cells are going to be what we are going to call it as a benign, what we are going to call it as. So actually, I'm talking at a little bit higher level actually. Malignants are nothing but positives. Benign data are going to be nothing but negatives actually. So which one is going to be costlier? So we have something called as an cost of the model actually, guys. Obviously, every model will have some cost. That means if a positive predicted as a negative or a negative predicted as a positive, so there is going to be some cost actually, guys. We call them as an false positives, and we are going to call it as false negatives. We are going to call it as. So for every model, we are going to be having some cost. So which one is going to be having the minimal cost? That is what we are going to be generally we are going to be selecting actually. Yes. Okay. So obviously all errors are going to be make some cost, but whether it is going to be how much it is going to be costing. For example, if a non-cancerous patient is predicted as a cancerous patient, the cost is going to be only a matter of money, because he will go to some kind of a test and do all these things. He has spent some money on that. But a cancerous patient is predicted as a benign data, as a non-cancerous cell. It's not a matter of money. It is going to be a matter of which is going to be a cost of a life of a person actually. So we have to follow some ethics. We are going to follow some kind of an ethics also there actually, guys. So there is going to be something like ethics in data science actually. So which one is going to be more costlier? Which one we have to, what type of ethics we have to follow? So depending on that, it is going to depends the cost of that. Okay. So obviously every model is going to be do some errors, but how much it is costing to the company, that is going to be this actually. Fine, Venkat. Yeah, guys. I have been. There is an option called as an while you are chatting, you can send it to everyone. Okay, you can send it to everyone. So I forgot to change the option. Now I have been send it to. I changed the option. So please, whenever you are chatting something, you have to share it to everyone. Actually, guys. Yes, guys. One of our guy has been one of our participant is asking, like how it will impact the business if the prediction models goes wrong. That is what we are talking about. Okay, fine, guys. So some of them are going to be more costlier, guys. Some of them are going to be less costlier. Okay, fine. So anyhow, machine learning is all about a predictions. It's all about some kind of a predictions only, guys. So predictive models we are going to be developing. And I told you about like what we are going to be, what are the different process in these predictions actually. So machine cannot directly learn by themselves actually, guys. Just quickly, guys, just once again review in the last class. So first of all, we have to do some kind of a data collections. So we are going to learn all the techniques of how to do the data collections actually. Sometimes the data is going to be there in a different files, different formats. So how to collect the data from the various systems, that is what we are going to be learning as part of the data collection actually. After that, we have to perform some kind of an basic analysis. We have to do it actually, guys. some kind of a basic analytics. All of them are going to be, what is actually data science actually, guys? Data science is nothing but what we are going to call it as, which is a data driven science. Completely driven only with the help of the data. If no data, if data was really not there, we don't have this concept called as a data science. Everything is going to be driven by some data only, data collection. After that, we have to do some kind of a data analytics. Data analytics means some analysis we have to do, whether the data is in a proper format or not, whether the machines are able to learn from this particular data or not. All these things we have to do it actually, guys, a data analytics. And after that, we have to do some kind of some issues will come actually, guys. Some kind of a data cleansing is going to be gets done. Cleaning of the data, because always all the data is going to be not in a correct format. Sometimes some kind of an irrelevant data will come. Sometimes some kind of missing data will come. So how to handle that? That is what we have to see as part of the data cleansing. And I told you about something called as a data visualizations actually, guys. Like sometimes to make you understand the data, one of the key skill which a data analyst or a data scientist is required is a data visualization skills actually, guys. We'll concentrate more on this data visualization skills. Because as a data scientist, so tomorrow if you want to predict the models or if you want to verify the models, completely we have to depend on the data visualization only. So data visualization helps you really a lot. It is going to help you. So we have to work with that particular, the data visualization, we have to work with that. All these are going to be done manually by the user, guys. It is not automatically done by the machine. All this has to be done manually by the users only. It has to be gets done actually. And main important step I told you actually, guys, which is going to be nothing but train the model actually. Train the machine learning models actually, guys, ML models. So we are going to be having a different types of ML models will be there. So there are going to be some algorithms will be there. So using this particular algorithm, so we have to train that particular model. So model will learn. The machine learning models are going to be nothing but some kind of an algorithms. So they are going to learn that particular data. With the help of the algorithm, the models will learn actually, guys. So here only we have to specify the algorithms actually. This is the main process which the machine is going to do actually. And once the model has been trained or once the model has been learned, so how much effectively it has been got learned, which is going to be a kind of an evaluation. So how effectively we have been, as you're asking, as Venkat, you have been asking me, like how do you decide or how much it is going to be costing that particular. So we have to evaluate them. So how many errors it is doing. So before going for giving to the end user, we have to just do some kind of an evaluations. And then we have to improve the performance of the models actually. Improves the performance. We'll try to improve the performance of the models. So 90% it is predicting correctly. Why can't you make it 95%? Why can't you make it 100%? Something like that. And at the last, we have to do the deployment action. Deployment of the models actually, guys. Your ML models only we have to work with them. So here we are going to completely works with some kind of an ML models. The model is going to be get trained. The model is going to be evaluated. We are going to tune that particular model, and then we are going to deploy that particular models actually. That is what we are going to be gets doing this. Okay. So these are all some kind of an technical aspects. These are all going to be some kind of a technical aspects which we have to do it in our the data science actually, guys. In a data science project life cycle, we are going to be doing this kind of an applications. What we are going to do that. Okay. So first we have to do some kind of a data collections actually. A kind of a data collections what we have to do. Step by step, guys. First you collect all the data. Do some data analytics. You will find out whether that particular data is sufficient to learn or whether you want to, whatever the business problem or what are the problem statement you want to solve. If the data is not sufficient, so again, collect some more data. Then further cleaning is going to be required and try to visualize the data for understanding the data and train the particular model where the machine is going to learn. This is what the ML is going to do actually, guys. And after that, evaluation of model performance, this should be done by the user. Improvement of model performance. All these are done by the users only. Machines won't do that actually. There is something called as an reinforcement learning. where the model itself, the machine itself is going to train itself, machine itself is going to evaluate. I'll tell you that is going to be comes under AA part actually. This is machine learning what we are talking about, guys. After machine learning, we'll go to the deep learning. After deep learning, we'll go for the AA concepts actually. Okay, slowly we'll understand them, guys. Now at a time, we cannot understand what is DL, what is AI as of now. Okay, so today I'm going to add a small a technical terminology I'm going to be adding actually, guys. So one important point is actually, guys, once you come to the data science, don't expect that like other programming language, we are going to learn some programming part, some coding you can just by heart it, or coding if you just learn it and we can go for. No, it is completely a conceptual basis, guys. If you are completely familiar with the concepts, if you understand the concept, then only you can go for the implementations. Simply like other programming language, you cannot copy the code from internet or cannot copy that code and you cannot paste it here. It does not work like that. It does not work like that actually, guys. It's completely different. It is going to be different actually, guys. Data science is not all about programming. It is not all about Python. It is all about some techniques. We are going to learn some different mathematical statistical techniques we are going to learn. We are going to learn some kind of a methodologies. I'll tell you guys some methodologies we are going to use them actually. Some kind of a methodologies we are going to use them. And we use as a different type of systems we are going to use them. Finally, our target is to get some insights from the data. And based on some insights, we want to do some kind of a predictions what we are going to be doing it actually. Right. No, it's as I told you, no, it is not about a programming. It is not all about a programming. They are not kind of a programmatical skills actually, guys. They are completely different actually. They are going to be different actually, guys. Okay. It's all about some concepts, all about some techniques we are going to use it. So those concepts and those techniques we are going to, you are going to implement with the help of some kind of a Python we are going to be implementing actually, guys. So we are going to use Python, but learning a Python is not a complicated one actually, guys. Okay, just for a timing, I'll tell you one small technique actually. I'll tell you a small technique. For example, let us say there is some height of a person and there is going to be a weight of a person actually, guys. Let us say just height and a weight. So what is the height of a person and what is going to be the weight of a person is the whatever the data we are going to be having it actually, guys. Let us imagine that. Let us say that the height is going to be in centimeters and weight is going to be in kgs actually, guys. Let us say that. So let us say height 170 centimeters, weight is going to be 58 kgs. It is going to be, let us say 180 centimeters, let us say some weight of 75 kgs, or 165 centimeters, we are having some 65 kgs, or something is the data actually, guys. Why we have to do that is a different, situation actually, guys. That is going to be a different situation actually, guys. Don't worry about that. Okay. So that is going to be what we are going to be seeing in the later applications. We'll see them actually. So what we are talking about here is, guys, what we are going to be talking about here is a simple technique we are going to be using it actually, guys. A simple technique we are going to be using this actually. So what is that particular technique here is, guys? Just an idea about that particular application is we are going to be using, that means, see, this data scale is a different scale actually, guys. This is going to be a different scale. It is maybe something around some 152, maybe 180 or something like this. This data is going to be in a different scale actually, guys. When we are doing some mathematical operations actually, guys, when you're doing some kind of a mathematical operations, so being the data is going to be on a different, scale, what will happen here is, don't worry, later we'll see about them, guys. Later we are going to see about them. So what is going to happen here is, they are going to be something like what we can say is, they will dominate actually, guys. One feature is going to be dominates the other one actually. One feature is going to be dominates the other one actually, guys. That's why what we are going to be doing actually, guys, we'll bring all of them into one common scale actually. We are going to bring all of them into one common scale. We have to bring it actually, guys. So for that, I'm going to use a mathematical technique. I'm going to use as actually, guys. It's a mathematical techniques we are going to use as. So there is a mathematical technique. It's not a programmatical technique actually. What we have to do actually, guys, there is, okay, later I'll tell you about that. Simply what we are going to do, guys, every data has to come into the same scale. That means this data has to come between 0 to 1. This data also will comes between 0 to 1 actually, guys. Further, there is a mathematical technique called as a min-max scaling technique is what we are going to use as actually. What do you mean to say min-max scaling technique, guys? Nothing is there. From every value, it is going to be, for example, if we treat the value as a x, subtract the minimal value divided by the maximum minus minimum value actually, guys. For example, if the height is there, what is the minimal value actually, guys? Minimal is 150, maximum is 180. So how do you scale this data actually, guys? 170 minus 150, this one, guys, 170 minus 150 divided by 180 minus 150. Second value, 180 minus 150 divided by 180 minus 150, because 180 is the maximum, 150 is the minimum. So maximum value will always goes to 1, minimal value always goes to 0. Here also what will happen actually, guys? The minimal value, for example, if it is 60 kgs, the 60 kgs will comes to 0 and the 75 is going to be comes to 1 is the value actually. So this is a mathematical technique. But how do you apply this in Python? Further, you don't write any code. Why we are using Python? Because yes, guys, Python provides you all these utilities to perform this kind of a scaling. So this is a mathematical concept actually, guys. This is a mathematical concept. It's not a Python concept or it is not some other concept. It's a purely mathematical concept. But how do you do this? How do you do this in a programmatical way? For that, I'm going to use as something called as in Python. I'm going to use as actually. Just don't worry. I just show you the code so that you can understand. That means some people may have a doubt. Like, sir, I don't have a programmatical skills. Can I learn it actually? As I told you, no, if you understand this mathematical technique actually, guys, this is not a programmatical skill at all. It's a min-max scaling. Subtract the minimal value from every value divided by maximum minus minimum. Minimal value will always comes to 0. Maximum value will always comes to 1. You take any scale of the data. You take any scale of the data, you can take it actually, guys. Don't worry about that. Further, just to show you the concept, I'm writing some small code actually, guys. Don't worry about that. It's all about some small scripts only actually, guys. It's not any programmatical part. We don't write like a C program, save the program, compile the program, execute it. We don't do all this actually, guys. Just a small technique. Wait, for example, 170, 165, 140, 155, whatever the data actually, guys, 180. Next one, what is going to be the height actually, guys? What is going to be the height? I'm going to take it actually. Just WT is a weight. Height, what is going to be height? Okay, first one is height actually, guys, not weight. Okay, this one is height and the next one is going to be nothing but it's a weight actually. Let us say something like 78, 67, 75, okay, or let us say 56 and something 80. Just an example, or let us say 74, whatever, maybe 72. Just this is going to be some data actually, guys. Some data. Let us say that. If you want, I can show you the data actually, guys. Don't worry. How I created, what I created, don't worry. It's going to be your data actually, guys. Just a minute. Right. So this is a height and this is a weight, guys. So height is ranging from 140 to 180. Weight is varying from 59 to which is going to be 78 actually. But I want to bring everything into a common scale actually, guys. Common scale means 0 to 1. I want to do that actually. So Python provides all these utilities in an easy way. Don't write anything. Don't worry about that. Just it is going to be, we are having some libraries actually, guys. These are all what we are going to call it as yesterday I told you. We do some kind of a pre-processing. We have to do it actually, guys. So a kind of a pre-processing, we are going to do it actually, guys. Directly, there is a functionality called as a min-max scaling concept is there. See, guys, I'm going to do that kind of a min-max scaling. I'm going to do that. Just I'm going to do the scaling actually. Don't worry. Actually, the outcome will come like this. The output will come like this. I'm going to again convert back to the same as it is. I'm going to be converting actually. Don't worry about the code actually, guys. Don't worry about the code actually, which is going to be the columns equals to, I said data dot columns actually. See the output actually, guys. This data we have been got converted into this data actually, guys. This data is converted into this data. Nothing change has been taken place. The importance, that particular, whatever the weight, everything remains the same. 180 has been got converted into 1 and 140 has been got converted into 0. Here 59 is going to be gets converted into 0 and the 78 is going to be gets converted into 1 actually, guys. Both of them has been came into 0 to 1 scale. If I show you in a graphical format, that means if I convert into some kind of an which is going to be a 2-dimensional space, if I represent, then we can understand the importance actually, yes. Then we can see the data. If I visually show the data, we can understand it. Points does not change us. Their weights does not change us. Only the scale has been changed. Point as it is remains the same actually, yes. So don't worry. Hope you understood why I'm talking about that. I didn't written any logic for that. I imported some libraries and I applied that particular min-max scaling we have been done. Here, what you have to understand, not how to implement min-max scaling. Why I have done the min-max scaling, you have to understand that. Okay, so here we have to understand here is why I have been done this particular min-max scaling. Why I'm doing that. If I understand that, how to do that, I'll do it in the Python applications. So hope you can see that I didn't written any code, I didn't written any logic, I didn't written any code for the min-max scaling. Already Python provide the utility. We are just using this and I'm going to be implementing this. Okay, so fine. I think his name, what is your name? Pawan Teja, right? Got my point, Pawan Teja? Yes, guys, please interact. It should be like a classroom training. It's not like a video training, no? So if you have the mic, you can just speak. Okay, if you have any questions, don't hesitate, guys. You can ask, you can raise your questions. I'll be always ready to answer your questions actually, guys. So please make it interactive session. It's not just like a video session. Video is playing and just we are sitting there and listening it. If you have any questions, only thing is, due to the pandemic, we are due to just a pandemic actually, guys. Due to this particular pandemic, this you are becoming this kind of an online classes we are making it actually. Otherwise, it looks like some completely like which is going to be some completely which is going to be looks like it's going to be completely looks like in classroom training only. It is going to looks like actually. Okay, fine, guys. So this is going to be all about. This is going to be all about how we are going to be gets working with them actually, guys. Okay, that's it actually, guys. That is going to be all about this particular one. So what I am trying to make you understand here is, guys, what I'm trying to make you understand here is understanding the math, that way the concept is important. Once if you understand that particular concept, then implementation is going to be nothing but which is going to be done with the help of a Python or with the help of some other thing. We are going to be doing this actually. Okay, fine, guys. Okay, now come to the discussion, guys. Today,
I also need to convert it into 0 to 1, sir. I know, like.
Yeah. Okay. Why we have to convert this into why we have to convert this means that it's a little bit a technique, like for example, let us say that do you know how to calculate the distance between two data points? Distance between two data points. Yes, guys. Yeah, who has been asking that doubt? Just do you remember how to calculate distance between two data points? For example, if x and y is going to be the two data points, if x points are x1, y1, and y point is going to be x2, y2. So how do you calculate the distance now? Yes, how do you calculate? x1 minus, it is x2 square, plus which is going to be y1 minus, it is going to be y2 square, and whole to the square root actually. Yes, isn't it?
Yes, sir.
Okay. So now if I'm trying to calculate, so see, this is one data point in a two-dimensional space. Like for example, if I make it as n, which is going to be it's a weight, and this is going to be the height actually. So height, which is going to be 170 and which is going to be 58. This is a point. This is 180 and which is 75 actually. So if you can observe carefully, whenever you are calculating the distance between this point and this point, for example, see this point actually 170, 58. This is 150, 60. So who is the more dominant here now? Any idea? Who is going to be the deciding factor here now? 170 and 58 is one point, and other point is 150 and 60 is going to be the other point actually. So which one is going to be dominate here now? Which attribute is getting dominating here now?
170.
Height is dominating.
Yes, sir.
Isn't it? So the contribution done by this is a very, very small distance actually, because this is only just 58 minus 60. So while you are calculating the distance between these two data points, this factor is going to be most dominant actually. That's why what we will do is we'll bring it to 0 to 1 actually. If we bring both of them into the same scale, now both are contributing some distance calculation actually. That is the reason why we have to scale the data.
Okay.
Okay.
Just to decrease the distance between.
Not decrease. We want to balance them actually, because one is dominating actually. One is going to be high dominating, and one is going to be, it's not contributing anything to the distance. If I bring it to 0 to 1, height and weight, both is going to be contribute some distance to us. Okay. Depending on that, we can decide which one is going to be closer actually. Okay. So once you go to the actual concepts, you'll understand it actually. Like for example, if I give you the data points like this is a data point, and let us say that this is a B data point, and this is a C data point. Now, can you tell me to the A who is closer? B is closer or C is closer?
B.
We cannot say like that. We cannot say like that. For example, if A point is, let us say that, just an example, A point is, as you can see that it is 170 comma, for example, if A point is, otherwise, I'll take in the easiest way. For example, A is going to be, okay, whatever it may be. A point is going to be 140 comma. Let us say that the other one is going to be with a small scale in between 0 to 5 only it was there. It is 140 comma 2, for example. Now, what is the B value actually? Maybe B value is going to be 150 comma. It's going to be like 150 comma, which is going to be something like we are going to be having a 3. Let us say that. C point is going to be having the same coordinates only with a small change in the value. So this value is going to be 140 and this is going to be 2. So, okay. So whatever it may be, or 2 comma 140, whatever you write it, it depends on the scale between them actually. It's going to be depending on the whatever the scale we are going to be representing actually. If the scale is going to be higher, this will automatically dominate with that. This does not dominate actually. So that is the reason we have to bring everything into a common scale. We have to do it actually. Okay.
Okay.
Fine. That's the reason that I told you. It's why it is going to be used. Later we'll see that actually. We have some algorithms called as KNN algorithms where we are going to do that actually. Okay. So let us come to the discussion actually, guys. What is my today's point of discussion is, as I said that machine learning is all about something what we are going to call it as prediction. So what it is trying to predict actually, what we are trying to predict actually, there is some number, some value it is trying to predict actually. Yes. So remember, so don't worry, just it is only introduction part actually, guys. Later, that means once you start with your actual concepts, once again, we'll have a complete discussion about that. Remember, just try to understand carefully, guys. In our data science and data analytics, generally, we don't talk about any data types concepts actually, guys. That means like a programming language, we don't talk about integers. We don't say that it is a float, or we are not going to talk about something like a string. We don't talk about any data types like this actually, guys. We'll only talks about types of values, but not type of data. We are not going to talk about a data type. Generally in our data science, there are two types of data. We use two types of values. We'll use it actually, guys. One is going to be nothing but it's a continuous data. and the other one is going to be nothing but it's a categorical data actually, guys. It's very easy to identify that. It's not, as I told you, once you move to the towards the data science, guys, all the terminologies will be changes, guys. All terminologies are going to be completely changes actually, guys. Your terminologies are going to be changes. You will get a kind of a new terminologies we are going to be getting actually, guys. We'll completely get some kind of a new terminologies we are going to be getting it actually, guys. Okay. So what are those particular terminologies are going to be nothing but a continuous data, and other one is going to be nothing but it's a categorical data. What is a continuous data actually, guys? Continuous data is going to be nothing but a continuous data is going to be nothing but, guys, a number. It is going to be nothing but a number which can be, I can't say that it should be only between this range only. It can be any value between minus infinity to plus infinity. We cannot say that always it should be there only in between these values. Like for example, what is going to be the temperature? The temperature or the some kind of an the temperature, whatever that may be, body temperature or it may be climate temperature, whatever it may be. It can be a negative value, positive value. We cannot say that the temperature should be only 30 degrees and 40 degrees only. It can be any number. It can be there actually. Yes, it can be any number. Like we can say that it can be 41.6 or it can be 36.8. It may be 42.2. It can be any number. Sometimes even it can be negative numbers also, minus 8.65 something or minus 8.6 something. Generally, whenever the data can be spread across a values like this, they are nothing but what we are going to call it as a continuous data actually, guys. Like temperature, salary, height, weight. So we cannot say that weight cannot be like only 150, some height can be only 150 centimeters or only 160 centimeters. We can't have it. It can be, it may be within a specific range only, guys. But we cannot say that it should be always only these type of a distinct values only. They are not distinct values, guys. They can be some kind of a continuous data actually. If you remember, like for example, in our college days or in our 10+2 standards, we used to call some kind of a functions. So let us say f of x is going to be a continuous function. What is meaning of f of x is a continuous function means it can just go, like for example, f of x equals to x square. It's a continuous function because there is no limit for that. It goes continuously, it will goes it actually, guys. That is what we call it as a continuous data. Continuous data means a numerical value which cannot have only some specified values only. It can be across any range with any different types of values. But what do you mean to say categorical data actually, guys? We can also call it as discrete values. I'll make it a more elaboration later actually, guys. We call them as in discrete values, what we are going to call them as actually, guys. What do you mean to say discrete values actually, guys? Discrete values mean, or a categorical data mean, only some kind of a specific values only possible. Only some kind of a specific values only possible. We cannot have different values. Like, for example, if you talk about a gender actually, guys. Gender is going to be, it may be a male or it may be a female. It's only just a two categories. Categorical is nothing but categories. So male and female. Or for example, something like, it can be anything actually, guys. It's not like that. For example, if I talk about some kind of a medical diagnosis actually, guys, it may be positive, or the test may be a positive, the test may be a negative, or it may be a one more, which may be failed. That means the test has been failed. I can't say positive, I cannot say negative. This test is positive for so-and-so disease or so-and-so virus or something, it is going to be positive. For this, I can say that it will happen. So this is affected. This is not affected, fail. I can't say. Diagnosis, positive, negative, or fail. For example, if I talk about emails, your mail, whether it may be a spam mail or whether it is going to be non-spam. Non-spams are nothing but it's a ham. So whenever we are trying to predict, or whenever you are trying to predict this kind of a continuous data, or whether you are trying to predict an categorical data. So as I told you, like I'll give the past customers data, tell me whether the customer will be a defaulter or a non-defaulter. So I will give all the previous emails. Tell me whether the incoming email is, which email is going to be, try to predict which email is going to be a spam or which email is going to be nothing but a non-spam. I'll give the past patient's data. So who has been diagnosed with some disease. So try to predict whether a patient will be positive or negative for that particular disease. So this type of data is what we are going to call it as a categorical or a discrete values. So remember guys, a terminology will changes actually guys, a new terminologies will come. If you are trying to predict a categorical data actually guys, if your machine learning model is trained to predict a categorical data, as I told you, machine learnings are going to be trained to understand something and to predict it. So if the machine learning models has been trained to predict a categorical data, those types of tasks are what we are going to call it as. What is meaning of categorical guys? We are trying to identify. So whenever I given this particular person's height and a weight, can you predict whether they belongs to male or a female? So you are doing some kind of an separation, classification actually guys. You are trying to classify or you are trying to predict whether this particular person is a male or whether it is a female. That kind of a task are what we are going to call it as a classification task actually guys. So a new terminology has been came actually guys. You have been never heard about in any programming language. Normally in programming language, the terminologies are guys, variables, data types, declaration, okay, conditional, control. Okay, you will be having only these topics actually guys, functions, okay, strings, only these techniques are there. But here it is not like that. So whenever you are trying to train a machine learning model to predict a categorical data, that is what we call it as classification. Easy to remember. Classification, categorical, easy. So whenever your model is trained to predict a continuous data, it's a very, very, very new terminology, guys. It is going to be nothing but what we are going to call it as a regression task, what we are going to call it as. So don't worry, again and again we'll discuss. Your actual machine learning discussion will start. That means in our actual course curriculum, this is only introduction part actually, guys. When you go to the actual main part of the machine learning, again 3-4 days, again complete introduction will be taking place. And anyhow, prior to that only we'll understand what is categorical, what is categorical, what is continuous data. We'll understand them actually, guys. So basically we'll work with either a continuous data or a categorical data. Continuous data means the data which can spread across a range of data with not with a limited number of values. What is going to be discrete values or categorical values? Where that, don't think that it should be always only like a male and a female. Even it can be 0 or 1 also we can maintain. Male is 0 and female is 1. Spam or ham, maybe 0 or 1 we can maintain. 0 is a spam, 1 is a ham actually. So don't think that it should be always a kind of a text data only string data need not to be there. 0 and 1, which is going to be nothing but how many children a particular person is having. So let us say that an employee in a company, how many children they have? It can be 0, that means no child, 1 or 2, maximum 0, 1, 2 possibility. There is a chance that maybe some there are going to be some people, some families are having let us say 3 or 4 or 5 also possible. It's possible actually. So 5 children, 4 children, 3 children possible. But beyond that, we cannot say that it goes from 0 to 100. It never goes about that. And one more thing, we cannot have like 1.1. We cannot have a 2.4. We cannot have a 3.5. Either 0 or either 1 or either 2 or either 3. Maybe not more than 5 we can say. So this is what we are going to call it as a categorical data. How many categorical values are there? There are 6 values are there. 6 categorical values what we have. Got the point, guys? So categorical data means don't think that all numerical data are continuous and non-numerics are categorical. No, it can be anything, or sometimes it can be like this also, guys. Whether this particular employee is having the child or does not have the child. There or not there only. 0 means not there. 1 means it is there. How many there? I don't bother. 0 means no child. 1 means a child is going to be there. It's a categorical data. Okay, so sometimes don't think that every numerical value is a continuous. So hope you understood it. Hope you understood the basic thing actually. Yes. Categorical data means only whenever we have some kind of a limited number of values. A very few unique values will be there. then that is what we call it as a categorical data. What is a continuous data which can spread across a range of data, and where we don't say that they can be only this value. What is the salary of a person in a company? So the salaries in a companies, it cannot be like only 10,000, 20,000, 30,000, 40,000. It's not like that. It varies. We cannot say that 33,625, 34,825, 40,620. You can have a different values can be there. Those are what we are going to call it as a continuous data. It's also even it's possible even if you have 10 also not a problem, but it is a categorical data, because the people who are having 0 children, the people who are having 1 child, the people who are having 2 childs, the people who are having 3 childs, it's a classification. Even it goes up to 10 also, we call it as classification, because it cannot be continuous data. Number of children cannot be continuous, it should be categorical, isn't it? So only these values will be there. We cannot have all the values. Okay, so that is going to be what we call it as a categorical data. Anyhow, that depends on how we see the data actually. Yes, we'll see that once you go to the application, how we are trying to see the data, in what way we are trying to see the data, because your continuous data will be seen in a different way, whereas the categorical data are going to be seen in a different way actually. So what type of analytics we do also will change us actually. So anyhow, once you go to the actual concepts, we'll understand those particular techniques. Okay. So that is going to be just an idea, guys. Just if you, it's not a mandatory to learn it, but if you just want to study, I told you 2 terminologies actually, guys. One is, first of all, what is continuous versus categorical data? Just, I'm not trying to, I'm not asking you to learn the things actually, guys. Just an idea, like what do you mean to say categorical data? What do you mean to say continuous data actually, guys? Like you can see, categorical variables, also called as discrete variables. This comes in only a fixed number of values, like dead or alive, obese, overweight, normal, underweight. So like, which is going to be some category: underweight, ideal weight, normal weight, overweight, and obese. There are 4 classes are there. Something we are going to be having the scores. What is going to be continuous variables? This can have any values between some theoretical minimum and maximum, like something like a birth weight, BMI, temperature, something called as a neutrophil count, whatever it may be. We cannot say that always it should be like this only. It can be across some kind of some theoretical minimum and maximum values. I cannot say that it is from minus infinity to plus infinity. Height is there. We cannot go to height of which is going to be like 200, 300, 400 centimeters. Up to some extent, it will be limiting, isn't it? We cannot have a 0 height actually. Minimum, whenever the birth takes place, so minimum height is going to be this much. We cannot have a 0 centimeters, 1 centimeters. We cannot have it. So theoretically, from minimum to maximum values possible, but we cannot say that only these kind of a values will be there. So that is going to be like, you can see, like birth weight, what is the BMI, what is the temperature, what is going to be the neutrophil count, something like that. There are going to be gets called. So try to read some articles actually, guys. Try to just, I don't prefer to say that I'm not recommending any websites actually here now, but we can just try to understand what do you mean to say a categorical, what is meaning of which is going to be continuous data section. The next one, which is going to be nothing but, guys, as I explained you, which is going to be what is classification versus what is regression. So regression is a new term actually, guys. Initially, when you started learning the data science, some terminologies does not comes to your mind suddenly, because it's a completely new term to you. Even classification, at least it can be remember, classification, categorical, but regression means you have never heard that particular word. Maybe some who has been done some maths, bachelor's in maths or something like that, those may be heard about the regression. Otherwise, you have never heard about this particular, the term called as a regression in your life. So regression is a mathematical concept, which it is going to explain the variation between the 2 variables actually, guys. So don't worry about that. Just an idea about, you take any website. I don't recommend some like I have to go to these websites and this one. Later I recommend you like which websites we have to follow, which websites you should not. We recommended we have to follow them actually, guys. Okay, so if you can see, there are going to be, you can see it actually, guys. Difference between classification and regression in machine learning. So just let me take some time, guys. Just it's already 10:30. Okay, no issue. So there is an important difference between classification and a regression problem. Fundamentally, classification is about predicting a label, some kind of a label, male, female, etc. Regression is all about predicting a quantity. So you can see some examples also actually, guys. So we can see some kind of an examples what we can see it actually. Don't worry about all the maths and all these things behind that. Some examples we are going to see it actually, guys. Okay. So a specific email of a text may be assumed the probabilities of 0.1 as being as a spam and 0.9 as being as a not spam actually. Spam and non-spam. This is what an example of a classification task actually. What are going to be the regressions actually, guys? For example, a house may be predicted. The house price may be predicted to sell for a specific dollar value, perhaps in the ranges of something like 1 lakh or 100,000 to 200,000 actually, where they are trying to predict some kind of an continuous data actually, guys. It is trying to predict some kind of an continuous data is what we are trying to predict. So mainly in machine learning, we have to understand these two techniques actually, guys. So which one is a classification task and which one is going to be nothing but it's a regression task. You can see a simple examples only. I went to a little bit complicated one, but you can just go through some kind of a simple examples. We can go it actually. Don't worry about all that particular algorithms, but examples we can see it actually. As regression algorithms, can we use it to solve the regression problems like weather prediction, house price prediction? Classifications can be used to solve the classification problems such as identifying the spam emails, speech recognition, identifying of cancer cells, etc., etc. And I told you, classification algorithm prediction is a discrete variable, whereas a regression algorithm, the outcome is going to be nothing but it's a continuous variable actually, guys. Okay, leave it, does not matter with that. Classification algorithms are used with discrete data, whereas a regression algorithms are going to be used with a continuous data section. Okay, so don't try to just read some articles just because we are still in the beginning concepts only. So no worries about that. Just try to read. If you try to explore some on the internet, you can find out this kind of a techniques, what we can find it of actually. Okay, so that is all about the today's class, guys. Already we are just running late actually for today. So hope you have got some idea about the some little bit, guys. Day to day, we are adding the things actually. First, I told you about what is machine learning. We'll give the data to the machine will learn, and based on that, we do the prediction. Second level, we have been studied about that. Like machines won't study automatically by themselves. We have to collect the data, we have to do some analytics, we have to clean them, we have to visualize them. Then we have to train the model, then evaluate the model, improve the model, deploy them. So today I added some extra discussion. What is the discussion I have done is, depending on what the machine learning models are predicting, or for what purpose we are training the machine learning model to predict, depending on that, whether it is a classification or whether it is going to be regression task. Actually, they are called as supervised learnings actually. Mainly your machine learning is classified into three types. One is going to be supervised learning. The other one is going to be what we can call it as unsupervised learning. And the third one is going to be what we call it as a reinforcement learning actually. So you can't understand what is that, what is currently them, but later we are going to be discussing about, which is going to be, we have three types of learnings actually. One is a supervised, and the other one is going to be an unsupervised, and the third one is going to be nothing but it's a reinforcement learning. Reinforcement learning is going to be comes under AI, whereas supervised and unsupervised learning is going to be where we do with ML and with DL we do the supervised and unsupervised learnings actually, guys. So with ML and DL we are going to use as the supervised and unsupervised learnings. Reinforcement learning is going to be done with the help of an AI applications. We are going to do that actually. Okay. So anyhow, we'll see. First, initially, we'll start with supervised and unsupervised learnings, and then we'll go for the reinforcement learning at the last class. Okay. So that's it for the today's class, guys. And we'll stop it for today because we're already running at 10 minutes late. So guys, anyone guys, any questions? Any questions, guys? If you have any questions, I can just spare it 5-10 minutes of time. You can unmute yourself and you can speak, or you can type it. No one, guys? Okay, It looks like nobody has been having any questions for
Sir,
the today's.
what will be the duration of this course?
It's a 5 months course.
Okay.
So 5 months, because we have ML, DL, NLP, all these are going to be there. No? So it's a little bit time taking process. It's not like a programming part. So a lot of concepts you have to learn. So it will take 5 months of time to take it.
Hi, Vamsi.
Yeah.
Sandeep here.
Yes.
How many months will take to complete ML and DL? Only ML and DL.
1 month is ML, 1 month is DL, and it's a prerequisite is 1 month. So totally 3.5 months it will take it.
Yeah. Okay. Vamsi. Thank you.
Okay. Fine.
Yeah, hi Vamsi.
Yeah, hi.
Manish here.
Yeah, Manish.
Yeah, Vamsi, I have one doubt. Like
Yes.
currently I'm working as a Java developer, okay?
Mhm.
And if I'm looking for this course, so what will be the career opportunity? Like in industry, like if I've completed and I have done all the training and I'm good in the like technical, all the things.
Okay.
So I'll get the opportunity in market
Yes,
for data
absolutely. See,
science.
yeah, absolutely you'll get it. But only thing is what you have to do is being you're already experienced. Let us say that how many years of experience you have in Java?
4.6.
Okay, 4.6. So what you can do is maybe somewhere around 2 years you put it on the Java, and another 2.6 months or 2.6 on the Java, and 2 years on the 2 years on this particular data science. What we can do that, and if you can
Okay,
just
so
correlate, just it's going to be because you're already having a real time experience. So some kind of
okay.
so like if you can justify, like when you go to an interview, so why you have been moved from Java to this one actually, because Java is a different technology. So one of the reason is going to be nothing but for a better opportunity. That is one thing commonly anybody can say that actually. But if there is any possibility, like your existing project is having some data, you can just correlate them and you can show some kind of an experience and a kind of a project. Otherwise, we have to show
Okay.
as a complete different projects we have to show.
Yeah. Thank you.
Fine. Yeah. Anyone guys? Any more questions?
One more question is there, sir.
Yeah, Bharat.
Actually, I want to know what kind of task we are going to do in industry, in data science and ML and AI. Actually, I have heard about this course only, but actually what kind of things happen in the industry that I don't know.
As I can just okay, that is fine, guys. But you have been seen, no, like in introduction part. Have you attended yesterday's class or today is your first class?
Today is my first class.
Today is the first class. So I told in the beginning, like what task we are going to be doing that actually in your industry, what task we are going to do that. Like we have to do some data collections, we have to do some data analytics, we have to do some kind of. Are you talking about the implementation or the use cases you are talking?
Implementation.
Yes, implementation is this one: data collections, data analyzing, data cleansing, data visualizations, developing of ML models, training the models, evaluation their performance, improving of performance. These are all going to be nothing but the day-to-day activities of the whatever that machine learning expert is going to do. So actually,
and sir, what will be the use cases for
use
this?
cases is nothing but, as I told wherever you want to do some predictions, like in finance, like we want to predict in a banking, so who could be the defaulters, who could be the non-defaulters. In medical diagnosis, positive negatives, like in e-commerce sites, recommendations, whether this customer will buy the product or whether customer does not buy a particular product. So recommendations engines. So almost all every day-to-day life we are working with the based on that particular ML applications only. So to which customer, what kind of an ad I have to send it actually. That Google and all these Facebooks will send the ads. It is like a customer specific. Whatever the ad I get will not be the same ad for you actually. Because how, based on my interest, based on my usage of internet, I'll get some different types of ads I'll get it actually. So which ad should be sent to which type of a customer. So all these are going to be comes under the predictions which are done by the machine learning applications. We have a lot of areas are there. It's not like this or that. Every area we are going to be having, even in the as part of your the training systems. Like for example, in corporate levels. So which employee should be trained on which technology it has to be there. So what type of skills he has to learn for the future. So all these kind of predictions is going to be done by the machine learning applications. Okay.
Yeah, Vamsi, one question.
Yes.
So today this is my first session
Okay.
today. So once I enroll this course,
Mhm.
so you will start this course from a scratch again once like you start the course, right?
Yeah. First, we'll start with the Python. So these are all only introduction classes actually. So we'll first
Okay.
start because first of all, what is data science? So many people does not have any idea about data science. In first class itself, if I start with the Python, why you are learning Python, first of all, you don't know. So today, I think you got an idea. So we are using Python purpose is to implement some kind of a techniques. We are using the Python actually. So for that particular
Okay.
purpose, we are going to learn the Python. So initially, I'll start with the Python. There is a 15 days class will be there. And you can also, that means anyhow, you will get a follow-up mail. In the follow-up mail, will have all the course contents will be there, but just giving an idea. First, we'll start with the Python. 2 weeks it will be there. After that, we have some prerequisites like NumPy, Pandas libraries are there. First of all, we have to work with them. And after that, we'll go to some data visualization by using Matplotlib. So to start with the machine learning, almost all it is going to take more than 1 month of time. Immediately within first class, we don't start with ML. Okay. So
Okay.
all the prerequisites, whichever that is required, I'm going to teach you in the class.
Okay. And it would be helpful if you will tell like what will be the fee structure. I don't have any idea
Yeah,
about
fee
that.
structure and all these things, my backend team, our backend team will be there because I was only a technical consultant trainer for DURGASOFT. So if you have any technical questions, I will answer it. Fees and all these
Okay.
things, my backend team will contact you. So you will get a follow-up mail, you will get it. But initial, because I know that fees, it is going to be 16K is the whatever the fee structure. Remaining, whatever you want to negotiate or whatever you want, you can just talk to my my backend team.
Okay, Vamsi.
Okay.
That information is helpful for me. Thank you.
Thank you.
Sir, one more question is
Yes,
there.
absolutely.
Actually, I am a web developer. Actually, I'm working as a full stack developer.
Okay.
Yeah, but I'm not understanding any one reason to study this course. Will it will be helpful for progression in my
It's a completely different profession actually. See, developer, development, and this is completely different actually. So here we cannot say that he was a software engineer because we don't write any programs or we are not going to write any logic. So see, data science is all about something like what I can say is a mathematical solution for a particular problem. So to solve a particular problem, there is a mathematical solution. So what you are trying to do is we are trying to apply that mathematical solution to solve a problem. So what is that mathematical solution? How it has been arrived? That is what we are going to be studying here. So that is completely different. So what is the reason why you are planning to shift from a full stack UI to data science actually? What is the reason basically? Yep.
Actually, for higher package, one of the reason is that.
But UI is also good, no? Right now, UI is also having a good packages, and you have a good demand is also there.
Basically, I don't know exactly.
Okay.
Yeah.
Fine. Okay. It's basically the thing is, in future, see, it's not the concept of the earning salary or packages. It's not there. In future, we have to depend on everything is getting intelligent. Everything. Say in coming future, how the machines will become intelligent here is we don't have. See, already we have we don't going to be having any we don't have any ATM cards. Just go to the ATM machine. ATM machine will be there, but you don't have an ATM card. So can you tell me how the ATM machine will identify you then?
Basis of biometric or something
No,
else.
not even biometric also. No need to touch it also. It's based on your photo. It's based on your image. Or it may be based on your voice. But we know that if you make it so, you know the point actually. I think whenever we say that it is based on the image, maybe what happens here is machines can also do some mistakes. Machines also do some mistake. For example, as you know that, so some people will be having very identical will be there, very closer. Then what will happen here is there is a chance of having a fraud because the same image, like a same person, if it goes and stands there, it will recognize as so and so Vamsi and transaction can be gets done actually. So there is a lot of research is going on currently. It is currently an emerging technology. So complete future is going to be based on this only. That is the reason. So based as the future, we are going to be depending on this. That is going to be becoming, it becomes very, very, mostly it is going to be used and implementation will be there. That is the reason for better opportunities and more opportunities we are learning. It's not based on packages or something like that. So being there is a future is there, we are going to be learning actually. And I think you know that as you are a UI developer, so you know that how the changes has been taken place. Now almost all it has been automated. No, so like a normal, a person who is a normal, who do not have any idea of a web development, can I develop a website?
Yes.
Yes, isn't it?
Yeah.
So
yeah.
obviously you are going to be having, everything is getting automated. Automatically the number of opportunities will decrease. As tomorrow in future, we cannot have some more and more, we cannot upskill yourself, or you cannot have a good opportunities. So the basically the reason here is in future we are going to be getting more and more opportunities will come. That is the reason why the people are learning about that actually. But it's not in whether you are a UI developer or whether you are a non-programmer, anybody can learn this particular data science, because it is not about programming, it is not about development, it is all about concepts. Fine.
Yes. Thank you.
Hi, Vamsi.
Yes, hi.
Quick
Yes.
question.
Yes,
Maybe
yes.
it's out of our syllabus
Yeah,
here. I'm trying to do something here. That's the reason I'm asking. So,
yeah.
which one is better, Google Colab versus Jupyter Notebook for data science, from your
Both
experience?
of them are same. Only thing is Jupyter Notebook works on a local file system, local system.
Right.
Google Colab is going to be works on the cloud.
Okay.
Okay, so if you
Like,
recommend me,
did
for
you see
example, if
any
I
kind of
ask
additional
me,
features like
yeah, but
yeah.
there are obviously there are some features are there, like it is going to be having a support of GPUs and TPUs, but you have to pay some money to that actually.
Okay.
It's not a free, no. So free means it will come with a free, but with a limited resources will come. But if you want to buy if you want to buy a GPU based machine, minimum it will be costing me somewhere around 70K. It will cost me.
Right. Yeah.
Okay. So in the case, for example, it's a startup company. They don't want to spend that much money on the computers. So with the infrastructure,
Right.
then you can pay some money to the Google Colab and you can see the powerfulness of GPUs and the TPUs. You can use them.
Right. Yeah.
Isn't it? So it depends on your usage. So see, if you ask me, for me, Google Colab is very convenient for my training, because directly Google if I write the code in the Google Colab, directly it will be saved in the drive. It will be directly shared to you when I share the files actually. But when
you can
I
access
don't
it
write it
anyway,
actually.
kind of thing.
Yes,
Yeah,
absolutely don't write them actually, because the people will get confused with that. That is based on the Unix operating system. Here in my local system, they will use as Windows operating systems. So that is a confusion guys will have. That's why I'll show the Google Colab. Some people will prefer to work with them, but sometimes we'll see some deep learning applications. They will take a lot of time on your local system. Then I'll say that work on the Google Colab.
Okay.
Fine. Okay, guys. Thanks for today, guys. It's already 10:51. Yeah. It's and beyond the whatever we have been planned. So thank you all of you guys. And tomorrow also, this week is almost all introduction classes actually, guys. So just please attend. Maybe tomorrow, Thursday, Friday, we'll take up the classes. And once the demos will be over, then we'll start up with the regular classes with the Python introduction classes. So by the time you have to do all your registration process and all these things, if we complete, you'll get that links and all these things will come. Maybe the next Monday, the link will changes. Before that, if you are really having a plan to take up this session, so you do all your registration process. For any further details, you can contact my backend team. You will get a follow-up mail. You will get a follow-up mail to you who has been got attended. You will get a follow-up mails actually, guys. There is a contact numbers will be there, and I mean even my backend team will try to contact you with your contact numbers registered. So if you have any further discussions, you can talk with them like fees and all these things. If you have any technical questions, you can discuss with me, guys. Okay. So thanks for today. Yeah.
Yeah. Do you use Jupyter Notebook for trainings?
Yes, I'll use Jupyter Notebooks.
From Monday? Yeah.
Not from Monday. Not from Monday, because I have to start with the initial. So I don't immediately ask you to start the Jupyter Notebook. I'll start with basically with the base system of Python I'm going to be working, which is IDLE I'm going to be using basically. First, I'll ask you to install the IDLE, basically Python from the python.org.
Okay.
Okay. After 1 week,
actually, some of us are using Jupyter notebook from
Yeah,
initially, so
you
that
may use this actually. That's because even if you're experienced also, I'll always prefer to say that first use Jupyter, first use the ideal, then only we'll go to the Jupyter notebooks later.
okay.
But once the
Yeah, thank
actual
you.
classes, main classes will start, so I'll start with that, but not initially in the first sessions only. I don't want to prefer it actually.
Yeah, okay, fine.
Okay,
Thank you.
this is my Jupyter notebooks. Every day to day classes will be happening in this only. But
Okay.
only thing is that is later. It's very first 5-4 classes only. Once I start with
Okay.
the if statements, for statements, I'll start using this. So, like for example, if you say this is completely Jupyter notebook, what I have been used.
Yeah, okay.
Okay.
Thank you.
So thanks all of you guys. It's a nice interaction also with all of you. Really, I'll appreciate them. And I like to talk to you else. Actually, it should be like a classroom training. It's not like a video training. So a lot of questions has been asked. So both technical and all these things. Very good to see you. Thank you for today, guys. And we'll see you in the tomorrow, same time, same link. Thank you all of you guys.
Thank you, Vamsi.
Yeah.
Have a good night.
Thank you.
Thank you.
Vamsi.
Bye.